Very good morning to all of you. Good morning to all of you. Archana, Sagar, Ganesh, Sabha. Very good morning and happy new year to you also. Okay. So sorry. Now you can hear me. Sorry. Okay. Very good morning, Rupesh Kumar. Very good morning and happy new year to all of you. Now you can hear me. Yes. Hmm? मेरी आवाज आ रही है आप लोगों को? आप सभी को नए साल की बहुत बहुत शुभकामनाएं. बोलो, कैन यू हियर मी? ओके, चलो. सबा, गणेश, अर्चना, ओमकार, दे ऑल आर सेइंग यस सर. सो गुड मॉर्निंग, हैप्पी न्यू ईयर. ठीक है. सो व्हाट वी आर टॉकिंग अबाउट, आई थिंक मे बी नॉट टुडे, इन द नेक्स्ट lecture we will finish this chapter, and in the next lecture we will start our last chapter, that is surface phenomenon, adsorption and absorption. ठीक है. So in this we were talking about the rate of reaction. So we will calculate the rate of reaction by different ways that we have seen, and today we will discuss one more important topic, that is collision theory. This collision theory means what happens in a gaseous state. The reacting molecule, they undergo collision. ठीक है. They are wandering here and there, and due to this phenomenon they undergoes collision. And due to this collision, so for example, suppose two molecule they undergo collision, they produce energy. And if that energy is equal to or greater than activation energy, then this collision molecule they undergoes, they get converted into the product. So please remember, those molecules which have collision, after collision they produce energy, and if that energy is equal to or greater than activation energy, only those molecule they get converted into the product, while other collision molecule they will not get converted into the product. So this collision theory or collision phenomenon is very important in case of gaseous state reaction, in case of gaseous reactions. So it is important to know that how many number of molecules they undergo collision per unit volume, per unit area, and that is called as a collision frequency. बहुत से सारे molecules say, for example, in a container or in a reactor we have taken 100 molecules of reactant, say 50 molecules of reactant A and 50 molecules of reactant B, and in that reactor they undergoes collision. ठीक है. Not all molecules undergo collision. ठीक है. Not all molecules undergo, not all the molecules they cannot undergo collision. ठीक है. So out of say for example 100, only 50 molecules they undergo collision. Only 50 molecules they undergo collision, and out of that 50 molecule, for example say only 10 molecules after collision they have energy greater than or equal to the activation energy. Only those 10 molecules they get converted into the product, while other 40 molecules they will not get converted into the product. So this collision theory or collision phenomenon or collision frequency is very important, and we can find out the rate constant K, which is called as a specific rate constant, by using a collision frequency, which is very important. We can find out a rate constant by using a collision frequency. We have seen we can find out the rate constant by different ways, by graphical method, by analytical method, by knowing T half of the reaction. Okay. By knowing the order of reaction we can find out the rate constant, but we can also find out the rate constant by using the collision frequency. How? That we will see in today's lecture. How we can calculate, that we will see in today's lecture. What are the different equation that we can use, that we will see. First let us see what is collision theory, what is collision frequency, and then we will see the equation how to calculate the specific rate constant. Okay. Okay, chalo. So we will start the lecture. We will start the lecture. This is your lecture number 8. of chemical kinetics, and today we are going to discuss collision theory of biomolecular reaction. Today we are going to discuss collision theory of biomolecular reaction. See here, a chemical reaction in a gaseous state. A chemical reaction in a gaseous state is occurs when molecules come in contact with each other. That I have told you. In a container, if you are taken in a container, and in that container we have filled gas of two different reactant, and they undergo reaction only when they comes in contact with each other. And this contact is provided by a phenomenon called as a collision. This contact is provided by the phenomenon called as collision, and I have told you already, the rate of gaseous reaction is depend upon the collision frequency. Higher is the collision frequency, higher will be the rate of reaction. Okay? So that we have discussed. Then we will see the definition of collision frequency. What is the definition of collision frequency? If you have pen and notebook, write down this collision frequency. Definition of collision frequency: the number of collision that reacting molecule undergoes in 1 second is called as a collision frequency. The number of collision that reacting molecule undergoes in 1 second is called as a collision frequency. So this rate constant can be calculated by using a collision frequency. How we will see? For example, we will take this equation: decomposition of hydrogen iodide into hydrogen gas and I2 gas. Okay? So decomposition of Hi into H2 and I2. For this reaction, we will calculate the rate constant by using a collision frequency. We will take this is as a model example, and we will calculate the collision frequency first, and after that we will calculate the specific rate constant for this decomposition reaction. Okay? So let us start. So here this reaction takes place at the temperature required for this reaction is 556 Kelvin. And at this temperature, the rate constant K is 6.31. See here, rate constant by collision frequency at this 556 rate constant. Here not rate constant. Here collision frequency is there. Here collision frequency is there. So collision frequency is 6.31 into 10 raised to 31 ml per ml per second, and number of molecules reacted at here, number of molecules reacted at 556 Kelvin is 2 into 10 to the power 14 per ml per second. So collision frequency, if you compare these two value, this is collision frequency. Yeah? This is not rate constant. By mistakenly I have written here K. So this is collision frequency. Collision frequency for this reaction at 55 Kelvin. Sorry, this is in Kelvin. Correct. This is the temperature unit. So collision frequency at 556 Kelvin is 6.31 into 10 to the power 31 per mole per second, and number of molecules reacted at the same temperature, that is 556 Kelvin, is 2 into 10 to the power 14. If you compare these two values, that means you will come to know that the number of molecule is very less as compared to the collision frequency. So that means what? That means what is the moral of this story? What we can say, whatever the number of collision occurs, all the collide molecules, they undergo collision, they will not get converted into the product. Okay? So see here, every collision that reacting molecule undergo is not converted into the product. So only those molecule undergo only those molecule will get converted into the product which possesses energy of activation greater than or equals to the A. Okay? So by using this specific rate constant, or by using this collision frequency, specific rate constant can be calculated from the collision frequency by using the equation. I have told you we can calculate the specific rate constant by using the collision frequency. We can calculate the specific rate constant by using the collision frequency, and the equation for this is the equation. This K is specific rate constant into Z. K is equal to Z into Q. K is equal to Z into Q. This equation we have to use. So what is K here? What is K here? K is specific rate constant. K is specific rate constant, and we can calculate the specific rate constant by using this equation Z into Q. And this Q is nothing but the E exponential minus EA by RT. This is the Q. So according to the collision theory, factor A, according to the collision theory, factor A of the Arrhenius, this is Arrhenius equation, you know that, है कि नहीं? ये Arrhenius equation है हम लोगों का. So according to the collision theory, A factor in the Arrhenius equation is equal to the collision frequency, which is equal to the collision frequency. Now let us calculate the collision frequency Q and specific rate constant for this reaction. This reaction, that is decomposition reaction, that is 2HI decomposes into H2 and I2, and for this reaction we will calculate the collision frequency. First we will calculate the collision frequency, then we will calculate the Q, and then by knowing this value collision frequency and Q, we can calculate the specific rate constant by using this equation. So Z is nothing but the collision frequency. Okay. So first we will calculate the collision frequency Z. First we will calculate collision frequency Z. According to the kinetic theory of gases, collision frequency Z is given by the equation. So this is the equation, Z is equal to, and this is according to the collision kinetic theory of gases. This is according to the kinetic theory of gases. Z is equal to under root 2 pi sigma square V into n star square. Now here sigma is diameter of HI molecule. Sigma is diameter of HI molecule. Write down this equation. This equation is very important. V is what? V is average molecular velocity, centimeter per second, and n star is what? N star is number of molecules per centimeter cube, and pi is nothing but the 3.14. Pi is nothing but the 3.14. Now you know all the value. Pi you know it is 3.14. Sigma you know that is diameter of HI. V you know that is average molecular velocity, centimeter per second, and n star you know that is number of molecules per centimeter cube. Okay. So by knowing this value, we can calculate the collision frequency Z at a temperature T and gas of molecular weight M. Then V is given by. Now we will calculate the V, that is average molecular velocity, and the formula for this is V is equal to 0.921 under root 3 RT by M. Here R is nothing but the gas constant, T is nothing but the temperature in Kelvin, and M is the molecular weight of that molecule, that is HI molecule, molecular weight of HI molecule. Now you know this value. R is gas constant, T is temperature, you know that 556, and molecular weight of M is molecular weight of HI. So we'll put this value, substituting the V in above equation. So you know V. Now we'll substitute this V, value of V in this equation. We will substitute the value of V in this equation. So we will get this. Z is equal to pi to under root 2 pi square n star square into V का टर्म है जो मैंने यहाँ पे लिखा है, into V 0.921 under root 3 RT by M. Now for HI sigma is 3.5 into 10 to the power minus 8. Molecular weight of HI is 128. N star की value है 6 into 10 to the power 20, and R is 8.31 into 10 to the power 7 hours per mole per Kelvin, and reaction takes place at 556 Kelvin. So we will put this value, all the values in the above equation. We will put this all the value in the equation, and after putting this value, so Z is equal to 0.921 जो ये है, then under root 2 into pi की value 3.14 into sigma square, this 3.5 into 10 to the power minus 8 square into this value n star की value into 6 into 10 to the power 20 square multiplied by this under root 3 into R is 8.31 into 10 to the power 7 into T is nothing but the 556 Kelvin divided by molecular weight of HI, that is 128. And after solving this whole term you will get Z is equal to 6 into 10 to the power 31 collisions per second. So we have calculated the collision frequency, and frequency is expressed in per second. Okay, so this collision is value of Z is 6 into 10 to the power 31 collision. This is collision frequency, and unit for the collision frequency is per second. Unit for the collision frequency is per second. Please remember this. So first we have calculated the Z, and that is nothing but the collision frequency. What we have calculated Z, and it is a collision frequency. And you know equation K is equal to Z into Q. Our aim is to find out the rate constant, that is K, specific rate constant, so that the Z की value आप लोगों को लगेगी and Q की value, and we have calculated the value of Z. Now we will calculate the value of Q. So here calculation of Q, if n dash molecule of total n possesses energy greater than or equal to the activation energy. I have told you every collision will not get converted into the product. Only those molecule which possesses energy greater than or equal to the activation energy, only those molecule they can get converted into the product. So this n dash is the number of molecule that possesses energy greater than or equal to activation energy out of the total number of collision, that is n. Out of total number of collision, that is n, at a given temperature T, then the fraction of total number of molecule n dash by n possessing energy greater than activation energy is given by Maxwell-Boltzmann distribution law. This is the Maxwell-Boltzmann distribution law. N dash by n is equal to Q. N dash by n is equal to Q, and the law is Q is equal to E minus EA by RT. E minus EA by RT. This is the formula of Maxwell-Boltzmann distribution law. Now energy of activation for decomposition of HI is given, that is 44 kilocalorie and 4400 calorie at 556 Kelvin. So we will put this value in this equation, or by using this value you can calculate the Q. How? Let us see. So Q is equal to here Q is equal to E minus EA by RT. So we will put this value. हम लोग क्या करेंगे? We will put this value. Calculation of Q. So here I will write here Q is equal to E minus 44000. This value I will write here. Then divided by R. R is 1.99. R is, so here R is in calorie per mole per Kelvin, because the energy की वैल्यू किस में है? कैलोरी की. So R की वैल्यू आप लोगों को किस में लेनी पड़ेगी? कैलोरी में लेनी पड़ेगी, and it is 1.99. So put this value here R, and temperature की वैल्यू कितनी है? 556 Kelvin, because कैलोरी टेम्परेचर केल्विन में है और R की वैल्यू हम लोगों ने किस पे ली है? केल्विन में ली है. ठीक है. So after putting this value, and if you solve this exponential term, you will get 5.2 into 10 to the power minus 18. So we have calculated the value of Q. हम लोगों ने क्या किया? कैलकुलेट किए Q की वैल्यू, that is Q is equal to 5.2 into 10 to the power minus 18. Now हम लोगों ने क्या किया है? First we have calculated the value of Z, then we have calculated the value of Q here, and you know that equation K is equal to Z into Q, that is specific rate constant. Now you can calculate the specific rate constant. ठीक है? Yes or no? We can calculate the specific rate constant value of K by using the equation. So here calculation of specific rate constant, last term जो कि हम लोगों का M था, and equation is nothing but K is equal to Z into Q. K is nothing but the specific rate constant. Z is the collision frequency. Now we'll put this value. K is equal to z की वैल्यू हम लोगों ने कितनी कैलकुलेट की थी 6 into 10 to the power 31 एंड q की वैल्यू 5.2 into 10 to the power -18 ये हम लोगों ने कैलकुलेट की थी. ठीक है. एंड इफ यू सॉल्व दिस इक्वेशन, if you do this multiplication, you will get 3.1 into 10 to the power 14 molecules. Unit is molecules centimeter cube per second. This is the specific rate constant and this is in molecules. And if you want to convert this in mole per liter per second, then what you have to do, you have to divide this value by Avogadro's number and multiply by 100. So we'll calculate the values in this unit, mole per liter per second. हम लोग इसमें कैलकुलेट करेंगे. ये मॉलिक्यूल्स में है. जनरली यू हैव टू आस्क इन मोल्स पर लीटर पर केल्विन. सो to convert molecules into moles per liter per Kelvin, what you have to do, you have to divide that this value by Avogadro's number and multiply it with 100. So here I will do it. 3.1 into 10 to the power 14 divided by Avogadro's number, that is 6.02 into 10 to the power 23 and multiplied by 1000. And if you solve this, you will get 5.2 into 10 to the power -7 and unit will be this, moles per liter per second. Okay, so in this way you have to calculate the specific rate constant by using a collision frequency. I have told you we can calculate the specific rate constant by using a collision frequency. मैंने आप लोगों को पहले ही बोला था at the starting of the lecture. We can calculate the specific rate constant by using collision frequency. So this rate constant of the gaseous reaction is depends upon the collision frequency. ठीक है. And we have discussed about the rate constant is also depends upon the temperature. And it is observed that if you increase the temperature of that reactions by 10 degrees Celsius, then the rate constant increases by 2 to 4 times. That we have seen in the very first lecture. ठीक है, याद है आप लोगों को? Rate constant is dependent upon the temperature, that we have seen. And if you increase the rate constant, if you increase the temperature by 10 degree of any reaction, then the rate constant increases by 2 to 4 times. But here, if you increases the temperature of gaseous reaction by 10 degree, then collision frequency does not increases by 2 to 4 times. Please remember this. It does not increases by 2 to 4 times. It does increases, but the increase is not 2 to 4 times. There is only increase in 1 or 2%. ठीक है. ऐसा नहीं है कि collision frequency टेम्परेचर इंक्रीज करने के बाद इंक्रीज नहीं होती, वो इंक्रीज जरूर होती है, लेकिन नॉट दैट मच. 2 to 4 times वो इंक्रीज नहीं होने वाली. इट विल इंक्रीज इन विदिन 1 to 2% ओनली. ठीक है. प्लीज रिमेंबर दिस. स्पेसिफिक रेट कांस्टेंट इंक्रीजेस विद इंक्रीज इन टेम्परेचर, व्हाइल कोलिजन फ्रीक्वेंसी increases with increasing temperature, but only a small percent, only in small amount. ठीक है. Understood this? If you have understood this, I think we will stop here because you know that today is first of Jan. New Year is there, and I will not take much time of yours. So enjoy your New Year celebration. If you have any problem in today's lecture, you can ask me. है किसी को कुछ प्रॉब्लम? बोलो. No problem, I think. नो, सागर इज सेइंग नो प्रॉब्लम. ओके, अच्छी बात है. कुछ भी नहीं कोलिजन फ्रीक्वेंसी में. नो सर. नूतन, संदेश, अर्चना, दे आर सेइंग नो सर. ओके, अगर प्रॉब्लम नहीं है तो अच्छी बात है. Okay, so I will active the link for your attendance. Give the attendance. Chaitanya is also saying no problem. Okay, chalo. No problem. Okay, I have activated the link. You can go and give the attendance. Once again, very happy new year to you. सागर is saying sir exam कधी आहेत? सागर तुम्ही exam form भरलेत का? Have you filled the exam for this semester? Please tell me that. सागर exam form भरलेत का? नो 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 नो. जर तुम्ही एक्झाम फॉर्मच भरले नाही तर एक्झाम कशी होणार? फर्स्ट यू हॅव टू फिल द एक्झाम फॉर्म. आफ्टर एग्जाम फॉर्म देन यू विल गेट द हॉल टिकट एंड देन यू कैन डू द एग्जाम. तो इसका डिसीजन अभी तक हुआ नहीं है. ठीक है, आई विल टेल यू द डिसीजन इज स्टिल पेंडिंग. जैसे डिसीजन हो जाएगा आई विल लेट यू नो. ठीक है. एग्जाम will exam online or offline, sir? Anthony is saying whether the exam is online or offline. Still it is not declared, Anthony. Once it is declared I will let you know very soon. ठीक है. Okay, no any problem. Any problem? So I have to conduct one more assignment. I will conduct one more assignment after this chapter. So two assignment is compulsory for you people. You have to give two assignment, two home assignment. 5 marks is there for two home assignment. So 2.5 mark for first assignment and 2.5 mark for second assignment. Second assignment I will conduct ऑनलाइन ओनली. जैसे कि हम लोगों ने फर्स्ट असाइनमेंट कंडक्ट की थी, तो same assignment I will conduct after this chapter. After the completion of this chapter, there will be 10 multiple choice question. You have to answer that 10 multiple choice question. And please remember, those who haven't given the first assignment, आप लोगों को second assignment देनी ही पड़ेगी. ठीक है? Okay. तो कुछ प्रॉब्लम नहीं है. इफ यू हैव एनी प्रॉब्लम रिलेटेड टू योर असाइनमेंट, रिलेटेड टू योर एग्जाम, यू कैन आस्क मी. अदरवाइज आई विल स्टॉप हियर. नो प्रॉब्लम. Okay, no problem. Shall I stop here now? Assignment based on which topic? Assignment based on chemical kinetics. Very good question, Rupesh Kumar. Very good question. Assignment is based on chemical kinetics only. Assignment आपकी chemical kinetics के ऊपर लेने वाला हूं मैं. So study. ठीक है. After this chapter I will conduct it. ठीक है. And I will let you know 2 days before. ठीक है. So you study hard. Your job is to study only. ठीक है. Okay. So if no problem है, किसी को कुछ प्रॉब्लम? अगर नहीं है चलो. So it seems that no problem. Take care. Bye bye. Have a good day and happy new year to all of you.